I'm super excited to introduce Derek Abdine as our next speaker. If you're on the tactical operational side of threat intel, you will have used some of the tools that he's been involved with back from his time at Rapid7 or Censys. That's very exciting. Where I actually geek out more is he actually did a Grand Theft Auto mod that got picked up by Rockstar. So, the gaming geek in me is instantly drawn to that. And I guess we can talk about some of the cyber stuff and the series of tubes that you're going to get into on the infrastructure side coming up here, Derek.
Yes, thank you for that intro, Rick. And thank you, everybody, by the way. I'm really excited to be here today and talk to you all about some of this stuff. Really just want to say thank you for choosing me and allowing me to be part of this talk and talk to you all, too, for all the attendees that came out and are listening to this talk today. It's pretty great. So hopefully you get something out of it. Let's talk about why data matters. I've been a little bit into the history of internet scanning, but just as a little bit recap of who I am. I'm actually coming to you right now from sunny Los Angeles, California. I have actually a nursery/office, but you can't see that. All this Zoom magic. You might see some little visual artifacts going on as I move around. I'm CTO at Censys right now. Prior to that, I was at Rapid7 Labs, as Rick mentioned. I have a history in doing network analysis. I've used to work on network, creating network analyzers back before publishing protocol information was a thing. So living in Wireshark or Ethereal, it used to be called, dissecting network traffic and trying to build analyzers for that on LAN. Moved that to the internet. Been doing that at Rapid7 for quite some time. Built out VM products and VM programs for Rapid7. Also done on the honeypotting side, so passive telemetry, global honeypotting. That's been something, kind of looking at those signals and how those relate to threat intelligence. While I was at Rapid7, I also represented the company for the steering committee of the Cyber Threat Alliance. So a little bit of a threat background there. More recently, some of my experience was in the 2019 economic report to the president. So that's a lot of great research was done by myself and some of the team at Rapid7 that incorporated a lot of the aspects of how the economy for the United States could be impacted by cybersecurity, and specifically looking at surface area analysis. Great team there, great research team for the folks at Rapid7. It was a really fun project to go through. I've been invested in hunting bugs and CVEs for quite some time, back into my teens and mid and early 2000s. Some of my first CVEs released, I still do that to this day. I have some published reports and articles more recently on some Tesla Powerwalls that were released. So I continuously look for that and find more ways to improve global cybersecurity risk by reducing it and helping everybody understand it better. That's where I'm here, and that's why I'm here talking to you all today. As Rick said, I have a little bit of a past. If I was to summarize it all, I would say hacking for educational purposes as well as gaming. I used to be into competitive gaming, so I did a lot of anti-cheat software creation, which required understanding how cheating worked and getting into cheating. Actually started to build an understanding of how game engines work and disassembling those and patching import tables to extend the value of the game. And that's how, Rick, you're mentioning Grand Theft Auto. That's how multi-theft auto was created. So a little bit of the open source gaming world came from that multi-theft auto mod, and the work that I did there with some of the co-founders of that mod. There's more contact information I'll have available, but if you'd like to get in contact with me, take a look at the Slack room that I have, the hallway. There's a little bit more information there, but you can hit me up on Twitter or LinkedIn, which whenever you prefer, or Carrier Pigeon if you know the avian carriers and you have pigeons available. Please send me a message that way too. I love to see pigeons every now and then, since I'm trapped in a room. But today I really want to talk to you about a few topics. And if you were to distill this entire presentation down into one thing, it's really that data truly matters, and it can impact our decisions when we're doing forensics. It could also impact our decisions when we're understanding the state of our public-facing infrastructure and how we're using that to defend our own networks. But that's the big point here. And to get there, I wanted to walk you all through a couple of different aspects. First, I want to walk you through a little bit of the history of the internet. So bear with me, we'll get there, because it's going to be a build-up now to this finale where we're going to start to discover some of the intricacies of the internet, telemetry collection, and how this all comes together. But then we're going to really go into a little bit more detail on adversary hunting, as well as looking at threat indicators and understanding how internet telemetry can impact our decisions with respect to those indicators. Let's move right along. So we all know the internet was invented in 1992 by Al Gore with, as Ted Stevens put it, a series of internet connected tubes. Actually, we know that's not necessarily the case. The internet wasn't created by Al Gore, and actually it was created quite a while ago through the Pentagon. The Pentagon wanted to start a research project. We wanted to create a network to link all their research institutions together, and they called this, came out of the ARPA organization, now known as DARPA. But ARPANET was one of the first. Basically the first version of the internet, and that reaches back quite a while, mid 60s, late 60s. By 1972, this is what a picture of the internet looked like. And you can see there's a bunch of different research institutions and military sites that are kind of all connected here. By the way, AWS is not your favorite Bezos website. That is Air Weather Service, I believe, which is part of the Air Force. So sorry, but there wasn't any foresight of creating a cloud back in this era. But really what you start to see here is, and the reason this is building up is because the internet is very vast. And we'll get to a lot more of this story as we go along here. But the internet's vast, and it really tells us the story of, ARPANET starting from these humble roots, going through TCP being introduced by around 1978 or so, IPv4, IP addresses that we all know today, main indicators that we look at on a day-to-day basis. The RFC for that didn't come out until around 1981. In fact, the first ISP, the World, it was literally called the World, didn't come out until around 1989. And the first user to actually log in, public user for the public internet, what would be called the internet at that time, was November 1989. So pretty crazy progression. But let's actually start to look at a little bit more of this detail. So what you're looking at here is a graph of free IP addresses over time. And this is really free /8. This is taken from Wikipedia. And what this is indicating is for the IPv4 address space and the adoption of that space, and a lot of folks starting to utilize it, because we had about 2.6 billion or so free addresses way back in 1996. And you see that dwindle down and down and down until today. We all know that we're pretty much completely exhausted from new allocations from IANA, and we have to depend on cloud providers or purchase IP addresses for large amounts of money in a lot of cases to really get those pools. What that means is it's a lot of plays. There's a lot of different hosts on the internet now. The internet's taken off. I remember, back in the mid to late 90s, logging on with dial-up. Everybody has a static connection. I'm coming to you right now through a fiber line. My internet connection's always on. I have, tens of Wi-Fi devices on different network segments as well in my home network. And there's lots of folks that are just running things constantly. And so that means that depletion means that there's even more telemetry to collect. And that creates a big problem for us. As defenders, we need to understand what the internet looks like, because that sometimes can inform our forensic investigations if we're doing any type of analysis. And that's where the main problem lies. We're always at that kind of disadvantage. So if you're going to go try to do any type of internet telemetry collection, you're probably going to run into several pitfalls. Now, I'm not going to go over each one of these because I'd probably bore you and it'd take a long time, and it would leave not enough time for the rest of the meat of this conversation. But, suffice to say, there's a few categories and a few themes here. The first one is that there's this theme of being blocked. So if you're going to go out and attempt, and by the way, I don't recommend anybody scan the internet, because if you ask Andrew Morris of Gray Noise, there are a lot of people already doing this. So you can depend on other folks that are already pulling this information and get it from those sources. But if you were to do it, and we need this information as defenders, what are the issues you're going to run into? The first thing is you're going to probably be blocked. If you scan IP1234, IP1235, IP1236 in the IPv4 address space, people are going to notice that. You're going to probably start scanning blocks that people own. They will start blocking you. They have rules. It's a pretty basic rule to catch sequential scanning. Same thing with ports. If you start walking ports, you're going to find that. So issues like that and that category of problems are going to be one of the first things that you're going to discover are going to get in your way from getting really high quality and accurate results back. The next thing, though, one of the more interesting things are transient issues. Transient issues we classify as more of this issue where you start to get drop packets. Maybe your packets took a route over a transatlantic or trans-Pacific cable and a shark happened to bite it that day. That happens. Their transatlantic and trans-Pacific cables can also get cut for various reasons. There's lots of incidents that are documented on it. That's one reason why. But there's also just routers are faulty on the internet. There's BGP hijacking, and we'll get to a couple other cases around that in a second. But all these different issues can kind of weigh in here. And then lastly, I kind of just throw it out there that sometimes you can't really take good measurements unless you're sending really good interrogation. And sometimes interrogation can also include authentication. In the case of UDP, for example, to understand if a service like SNMP exists, you really have to send a secret, the community string, which in some cases can be seen as authenticated scanning, which is a big no-no if you're in the US. If you're a country that doesn't have really treaties with the US on laws, then you probably don't care as much. But if you're somebody that's more westernized or in the US itself, you're likely going to be held accountable through the law, especially if you're doing anything through CFAA. You probably will violate the AUP of a provider that you may be scanning from. There's a lot of issues to deal with. To get really good data to help inform our decisions, there are all these issues we have to stay on top of. Now on top, just those aside, let's take a look at 3 different ways you could start to even collect this information and make sense of it. The first way that I'd like to talk about is single origin or single perspective scanning. In a single perspective scanning model, you have a server that's doing the scanning. You want to understand if some other server exists. And so you use some transit provider, you scan that packet that's routed over some wonky AS path, depending on what BGP wanted to do that day and how routers wanted to connect, eventually winds up at your destination. And you get some probe back, hopefully. Let's leave aside the shark scenario. All is good. But the downside to this method is you're only looking through a single looking glass. You're not really understanding what happens if I route through Europe or route through some other geographic location. How does the host look like from those different angles? You may also try a different model, which is what we call load balanced multi-origin scanning. So in this model, your goal isn't really so much the quality of the results, but the speed in which you obtain them. Scanning the internet takes a long time, even though through a paper that researchers produced called a Zippy or ZMAP, that was work related to the ZMAP project. It's an open source internet scanning program. They found that you can actually scan the internet in under 5 minutes. That's great. If you're going to do multiple origin scanning, though, that requires really starting to look at scanning one host through multiple different transit links that all take different AS paths and eventually go to different servers. That's great. You'll get the results back faster. But now you're starting to combine different origins all into one big picture. And you might find that maybe you scanned 2 IPs on the same IP block allocated to the same ISP or provider data center. And maybe you got a response back when you did that scan for the first IP, but not the second IP. And because they took 2 different paths and now you didn't have the same lens, you're combining those perspectives. So the third aspect here, though, is this concept of multi-origin scanning. So in multi-origin scanning, what happens is providers that produce this type of data, they scan by probing the same host through multiple different lenses of the entire internet. And they all take different AS paths and they all hit the same server. Let's leave aside BGP Anycast because that's a different topic in itself, but they all hit the same resulting IP address, I should say, and you get a response back. And now you can compare and combine those results and really start to get a union view, a kind of overlapping view, a holistic picture of what that specific IP looks like, depending on where in the world those packets are being routed from or to. So those 3 models to keep in mind. Each one of those models has slightly different implications on how you go about and what your results will end up looking like, and thus your decisions. But let's go a little bit deeper, just a tiny bit deeper now, because there was some research done on this topic on the origin of scanning, the impact of location on internet-wide scans. It's the links there and there at the bottom. And if you'd like my slides later, there's a links. It is linkified, so you can go follow that link and see the paper. But this depicts on the x-axis, so going across, how many origins that you would need to use. And then the y-axis, the amount of internet you're going to measure from essentially the low 90s to the 100% of the internet. And what the researchers found was that if you're scanning with a very small, with one origin, and you're using one probe, you're going to see roughly around 95 to 96%. That's interesting. You send another probe, you'll see around 97%. But as you go further and you get maybe 3, maybe 4, you start to see this diminishing return. There's like a logarithmic return on investment here, where just about like 3, you can start to see 99% or more of the internet by sending 1 or 2 probes. And that's amazing because as defenders, we need the best information to make the best decisions. And if we have a much 99% versus 96 or 95% of the internet is significantly different. That's a large number of hosts that can impact those results. All it takes is 1 host, during a forensic investigation. If you don't have that host and that data set you're looking for, that can create a hole when you're doing your analysis. And that's something we try to actively make sure that doesn't happen. So it's not only that, though. We know from the attack framework, so this is T1571 from attack, non-standard ports. We know various APTs and as well as malware like to run on non-standard ports when it comes to C2 services. So if you look at this and you're kind of starting to look at it a little bit deeper, I want you to look at this graph right now from a couple places. So snap your eyes to the very top, right under that 1.0. You see that purple line. Hopefully it's purple. I don't know if it's coming out the same color scheme for everybody, but that top line right under the 1.0 on the vertical right there, that's AMQP. What these researchers found in identifying unexpected internet services was that a lot of AMQP ports tend to be on the same specific, AMQP services tend to be on the same specific port. However, they only get up to maybe the diversity, how many different ports you tend to see AMQP on the internet, only went up into the like 10s. So that's interesting because if you go way down at the bottom now towards the 0.0 mark, there's a purple line there, another purple, darker purple line, and that's HTTP. And if you look at that very closely, you can see it going up to 10 to the 4 down there at the x-axis. Researchers found that in this paper that only about 3% of HTTP services live on the standard ports. Actually, you have to scan around 25,000 ports to really get 90%, a little bit over 90% of the entire HTTP services that exist on the internet. So that's staggering. We see that on a regular basis. We know that APTs and different types of malware, malicious software, rats or whatever, will take advantage of hosting C2 services at some point at some different port that's non-standard on the internet. So it's really important that we really understand that well and measure it. So just wanted to call that out is, we need to make sure that we have the best information, not only in terms of history, not only in terms of combining views, but in terms of having the most information of a host as possible to make the most efficient decisions. So if you're going to collect this information yourself, around 250 million hosts is about 500 gigs of data, or about 1.5 terabytes of compressed data per day. So it's a large volume of information to capture. And it requires, obviously large storage needs and likely large transit links to ensure that you can capture this information on a regular basis. But I want to take you back a little bit. I want to go back in time now. So we kind of fast forwarded a little bit. I want to take you 30 years after that ARPA picture that we saw, roughly 30 years. This is a picture of the internet in 2003. You can see, and this is something called a Hilbert map. So what this is each pixel on this image is the intensity of the pixel. I mean, the brightness indicates more live hosts within that specific pixel. Each pixel represents 256 IP addresses. So this is a pretty fun way to really start to visualize what's going on. Now, if you start to look at the internet in the 2003 era and you compare it to today, things get much more interesting. This is a picture from our friends at Rapid7. Bob Rudis, who's there, donated this picture to me. Rapid7 still releases data sets that are open source on their open data website. This is a Hilbert map of the world as Rapid7's data sees it. And you can see a lot of different intensities of pixels. You can see the black reserved ranges up there on the top right, multicast address ranges and so on. You can see a lot of different networks. So I think DISA's network, for example, is not necessarily well lit up because there's not a lot of hosts there since they're just allocating, they haven't really assigned it too much. But there's a lot of these different ranges that are intense. And if you even look at different providers, so this is a picture from our scanning platform, you see these more intensity. You see in different parts of the internet. So scanning from a different perspective, scanning from more perspectives provides you with more information back. Therefore, you're likely to get better results back. But if you were to actually flip between these two, I don't want to do it on right now because it's probably going to go slow for you. But if you were to create like an animated GIF of these, the last two, this one and the Rapid7 image, you'll see that even some of these pixel areas, some of these intensities, some of these parts of the internet are lit up more than other parts. And that's amazing because it also tells you that different ISPs, maybe different routers, maybe sinkholing scanners, maybe blocking specific scanner IP addresses and not. So you have all these weird intricacies of the internet that are all coming together all at the same time. One thing that I didn't mention that I wanted to bring up here too is that one other aspect of routing and telemetry collection is how censorship plays into this. So if you think about back to 2008, if anyone remembers the big YouTube outage that happened that time, that was a routing configuration error that was made with BGP that ended up blackholing a lot of traffic going to YouTube. More recently, there were some censorship issues with a Turkish ISP trying to block some DNS for, I think, trying to block Twitter or something. So the story goes, and that BGP routing issue propagated its way to the internet and disrupted a little bit of traffic for some major DNS providers like 1111, 8888, so on. So having these types of this type of activity, be it censorship, be it BGP issues, can create black holes that then would appear in these images, but also appear in your results when you're trying to look up these hosts and understand what's going on for these indicators. Let's take a practical example for now, and let's dig into that a little bit further. So we're going to look at a few vendors here. We'll look at two vendors, and we're going to look at combining those vendors at the end and understand how those results can kind of come together. So this indicator was taken from the FireEye indicator set that was released around mid-December for the SolarWinds sunburst activity. And so from this vendor that you would look at, providing this data in terms of how we're doing our forensic investigation, if we were to take a look at 3 different points in time, if you looked at point 1, you're not going to see much for this. You might not see any information at all for this host. If you look at point 2, you might come to the conclusion that that host was exposing port 22, just an SSH, which is pretty common for a lot of cloud services out there. And if you look at point 3, you're going to notice something pretty interesting, that the 3 different ports are now there. Port 22 may not have been open any longer. The host looks like it changed hands or was configured differently. So you start to see some story come together as you're doing this analysis. You can see this behavioral shift in how the host, this IP specifically, is exposing itself to the internet. This is, by the way, is from the time frame of last November. So this would be roughly the 16th through the start of December in 2020. But if you go further and you look at vendor B for the same indicator, so vendor B then saw at the first point in time that port 22 was open. At point 2, vendor B saw 8888 and 22 open. And then at point 3, you see a slew of different ports open. So the really amazing thing, and 22 and 8888 were closed by this time, but the really amazing thing is that if you combine these sources, you start to see an interesting story appear. So you can tell now that where vendor A didn't see anything before when you looked at point 1, you now know that vendor B saw something else. And that may be because vendor A and vendor B are scanning at different schedules. That may be because they are using different perspectives. They may be because one vendor is using more perspectives of the internet than others. But by combining this, now you have a more complete picture of what happened to that point. But the second point there is that the both vendors tend to agree that one port was open SSH. So you get higher confidence of the results too by combining these sources. And then finally, if you look at point 3, you get a union of these 2 ports. Vendor B didn't find ports that vendor A did, and vendor A didn't find ports that vendor B did. And that information on those 2 sets of data points can have significant impact on your forensic investigation. If some of those ports, for example, we know for the SolarWinds case, in some cases there were RDP services that were masquerading as customer infrastructure, that can have a significant impact if that information wasn't captured from one vendor, but it was by the other. So the big point here is by combining these sources, we can come out with better truth and maybe impacting, it might be an impacting event for the timeline that we discover, may even require us to go back and do some additional forensics on our data sets. So again, just want to recap a few points. Good internet telemetry collection is still a very hard problem. Let's leave IPv6 aside. IPv6, Google, I think according to Google, is only about 30% of the traffic coming to their services. A lot of times too, I haven't seen too much malware or too many APTs utilizing purely IPv6, because IPv4 is still a significant part of the internet and is the main choice of routing internet traffic today still. But that will change over time. And internet scanning is a hard problem. IPv6 will be even harder. The telemetry can also change how you look at your results and how you incorporate those results into your overall feedback and your overall investigation. It will differ between different vendors, and it's super important to combine them. There are some open source projects out there that will help. IVRE is one, kind of like an open source showdown, will pull from multiple sources. There's also other projects like Grindr. Grindr will pull some of this data in. So it's really important that you think about using those projects and how you can combine data from these sources to pull it in to your investigation, and then understand a little bit more about those data sources. What are they scanning from? If you can, you could probably do some WHOIS lookups on some of the scanner IPs that these researchers are using. Again, I know my friend Andrew Morris at Gray Noise probably has a ton of that information, but a lot of these scanner organizations that do scanning, Censys included, a lot of this information is publicly available. We just make it available because we want to be open and honest about how we do this telemetry collection. And then lastly, just want to say that combining your sources can lead to those higher quality results. And, again, think about this, not just from the forensic angle, think about it from the angle of defending your own network. The more of this information and the better information you can obtain, the better you can defend your own network, because presumably you'll find more interesting stuff. So that's all I had for today, and I'd love to take questions.